products this year related to my hobby of time nuttering, being insanely interested in precise time and frequency measurement. First, this is something we actually had out for a few months now. It's a pulse per second distribution box. If you have a GPS module or a GPS DO that has a PPS output and you want to send that to more than one place, you'd like to have buffered outputs to do that. And we've had a thing called the TADD which has been around for many years. It has 6 outputs. It's the 4 by 6 inch board size. It does everything that the kitchen sink could do, but I needed something a little bit smaller and simpler. So we came up with the mini version, which is available with 4 SMA outputs, the SMA input in the middle. It's also available in a slightly larger version with 4 BNC outputs. So that's been available for a while now. We have those available in the booth for sale today. I don't remember the exact price, I'm sorry. The SMA one is a little bit less expensive than the BNC because the connectors are less expensive. This is not advancing on left click, so. Okay, and this is really boring, yet still exciting. Thanks to George, K9 TRV, we have come up with a replacement for the old metal enclosure that we had for the TADD boards. We ran out of those 5 or 6 years ago. The company that made them for us was out of business, and to get that design reproduced would have been crazy expensive. But we discovered that the boards will slide into a Hammond extruded enclosure. So we cut that to the right length, and we get some inexpensive PCBs made for the front and rear panels. And that has worked out really nicely. We have a handful of those for sale today for the TADD boards. The picture shown at the bottom is the back of the TADD3, which is the one that has the most holes in it. The others are simpler. And we'll have custom boards for each of the 3 TADD types. You'll notice at the right there's a power pole connector. So we finally have a nice power input for the board. And all 3 of the TADD, 1, 2, and 3, will fit into this and work nicely. I came up with some acronyms, so I had to design some projects around them. So the first new one we're talking about today is the GUS, which is the GNSS Unfiltered Splitter. And this is if you have more than one GPS receiver that you want to run off the same antenna. And you have to be a little bit crazy to do that, but some people want to. You can buy antenna splitters off eBay or off Amazon. They're typically $100 or so if they have a case. At the lowest end, they could go up. The commercial ones here are $1,000. Almost all of the ones that you can buy have a filter in them for the L1 frequency, which is the frequency range that civilian GPS has used for the last 30 years. Which means that if you want to use a dual frequency receiver that uses the L2 or the L5 bands, it won't work because that filter cuts the signal out. You don't really need the filter in most cases. If you're at a cell site with a lot of high RF around, you might want that extra filtering, but in a home environment, it's really not needed, so it just adds expense as well as making it single frequency. So this board is a very simple 4-way RF splitter with hybrid combiners and a little preamplifier at the front. It's broadband, so it will work anywhere from about 1,000 megahertz up through about 1.8, where it starts to fall apart. It's designed in its simplest form to work like most of the splitters that are out there. You can plug a receiver into the first port, and the DC power that comes out of the receiver feeds through to the antenna to drive the amplifier in the antenna. However, there are times when that doesn't work, and on the circuit board inside, there are jumpers and configurations for every possible DC power configuration you could ever think of. A regulator that you can switch both its input and its output to go to different places, and you can enable and disable. The RF circuitry is like 6 parts on this board. Everything else is the DC, but it can do anything you need. By getting rid of the filter, it makes it much less expensive. I think we may actually be at the point where you'll be able to buy this for a little bit less than the typical one you find on Amazon or eBay. The board itself with the SMA connectors, and I think 1 or 2 little headers, is $55 for non-members, $50 for members. We will also have the enclosure for the same idea as the TADD. We don't have a price on that yet, but we're guessing that might be $40-ish. It depends on what the extrusions cost us to get cut to length and in volume. So we're kind of $90, and that's less than a lot of what you find could do. So we have something that is not only useful for time nuts, but actually might have more mass appeal, which is nice because whenever we can do volume in something, it lowers the cost and it also improves our profile if people are using our stuff. So this is a finished product. I'm waiting until Monday to order the production run of circuit boards because somebody might have a genius idea this weekend. If they don't, it'll go up Monday morning and we'll have them in the store probably in about 3 weeks. The enclosures may take a little bit longer depending on how long Hamvention takes to get us those parts. So I don't want to correction again. The other bad acronym is the Universal GNSS Listener Interface, or the UGLI. And this comes from the fact that you can buy breakout boards from places like SparkFun and Adafruit for all sorts of different GNSS modules, particularly the ones that UGLIS uses, which are very popular among not only time nuts, but people who are doing drones and precise positioning and things. But all those boards are different. They don't have any kind of standardized interface. So they often don't make all of the signals available from the chip that are there. And I got just fed up with that. So this is designed to be the last breakout board you'll ever need. The main board has multiple buffered PPS outputs. It has the direct USB path. It has voltage regulators to run from 5 volts or from 13 volts. It has a bridge chip, so you can take the UART TTL level signal coming out of the module, turn it into true RS-232. It has a bridge chip to make a second USB port, antenna power switching, everything in the world. And then the module itself mounts on a little daughter board, which is to the right in the upper picture. The bottom picture shows the mounted together. So we can have modules for all sorts of, or carrier boards for all sorts of different modules, and plug them in and they all work the same. Every signal that's available on the module itself is brought out and available on the UGLI board. So it's designed to really be a kind of Swiss Army knife, everything that you ever need. So these are the carrier boards that we use for the different modules. We want to support multiple different types. And right now, for the UGLIS receivers, which again seem to be the most common ones that hobbyists are using, there are 3 footprints of physical sizes that UGLIS calls NEO, LEA, and ZED. We have boards, carrier boards made for all 3 of those. The picture here is not our boards. These are just random breakout boards that I had to show the different sizes of the footprints. The left one is the LEA, which is the largest and oldest. The middle one is the NEO, that's the most common. And the right one is the ZED, which is what the new high-performance dual frequency units use. If you've ever heard of a thing called the LEA M8F, which is sort of a little GPSDO by itself, we have support for its special pins. And I already mentioned we have the bridges for RS-232 and USB. We can make these carriers for just about every GNSS module that's out there. I think there's a very good chance that we'll have one soon for one of the Trimble modules that one of the Hamside people is working with. So we want this to be an open design and make it accessible so that any module you have, we can create a low-cost carrier board and you can plug into one of these things. This is going to be available real soon now, but there is one manufacturing issue that's been bugging me. I'm interested in your feedback at the booth afterwards for how we approach it, and hopefully that's on the next page. So these UGLIS modules are not all that easy to solder down. The LEA and the NEO modules have exposed edges of the pads, and with a fine soldering iron, you can successfully solder them to a board. It's not the easiest thing in the world to do. It's doable. But the ZED modules have to be done with reflow soldering because the pads are underneath the module and you can't get at them. The picture in the upper right, you can see the back. Those pads are on the edges of the signals. The ones in the middle are ground. And the signal ones don't come out all the way to the edge of the board. So you have to have some kind of a reflow with either an oven or a hot plate. That's a problem because to get parts like that installed traditionally is really expensive unless you have a large quantity. And the ZED module is a $200 part to begin with. So it's a lot of investment if you're going to go out and order 30 or 50 of them and hope that you can sell them. We don't know how many people are going to want the thing, so we just don't know how to proceed. There are two options right now that we're looking at. One is to take orders to do a one-time run of this ZED carrier board, and if we get 25, we'll place an order with the U.S. contract manufacturer and get them fully assembled. The other alternative is to use the Chinese JLC PCB company, which can source these UGLIS modules. They buy them from like Mauser, but they pay about 25% more than you do, I think because of some sort of export tariff control or something for the leading edge technology. But the point is they can get them. And I've done the math, and on a per unit basis, we can have JLC PCB build 2 units delivered to the US for just about the same price per unit as the 30 units from the US contract manufacturer would cost. So if we do the US manufacturer, we have to have a big order. If we use the JLC PCB, we can batch up and do orders of 5 or 10 or something and be able to get products in hand a lot more quickly. I think we're going to opt for that second option. It provides more accessibility and gets things out of the market. JLC PCB quality is pretty good. The biggest problem with their boards is that they don't really withstand a lot of rework. If you're going in and soldering on them to change things, the pads can lift up and the mask gets burned away. But in terms of electrical functionality, they're absolutely fine, and their parts quality is good too. So we're going to have these available this way. We're probably going to do the same thing for a couple of the other modules. The NEO M8T is a timing module. It's a single frequency. It's been around for quite a long time now. If people are interested, we can get those made in the same kind of small batches. There is still the option to do it yourself. And I came up with a way to kind of get the best of both worlds because there's about 35 passive parts on the carrier board. They're all just capacitors and resistors. And normally, if you wanted to do the reflow solder yourself, you get a solder mat, stencil, you put the mask on, you have to place all the parts, and then heat it up. Well, JLC PCB can put all those little parts on for like 12 cents. So it's annoying that I have to hand place all those parts to be able to put the UGLIS module on later. I figured out that you can take the stencil design and enlarge the holes so that you can drop a stencil over a board that already has those parts mounted on it and still spread the paste for the module. And I've built a number that way and it works great. So if you're willing to do hot plate type soldering or toaster oven soldering, this technique lets you only have one part to worry about placing. I have a brief post about it on my personal blog at blog.fibo.com if you're interested. It's a really stupid, simple idea, and I don't claim to have made it up. I haven't seen it written up anywhere, but it's one of those things where once you think about it, it's blindingly obvious. So if you do your own PCB work and are interested, this could be useful maybe for some other projects as well. This is a combination of the last two things I've shown you. That's a stack of uglies with one of the Gus antenna splitter boards driving it. And this was sort of why I started this project. I want to do performance, timing, and location positioning comparisons of multiple modules of different types, but I want to have the same interface and be able to physically have them in one neat area so that it was not 15 boards spread all over the place. So that is a stack of 4 boards. Each of them has a different GNSS module on it, with different U-blocks, and then a slightly earlier version of the antenna splitter driving them. So that's the kind of thing that I end up doing. That's why I end up designing these projects, because I want to do some insanely complicated thing, and the easiest way is to build customized stuff to make it easier to do that. Finally, Dave talked a little bit about the clock module, and I've been involved with designing that. And what that is an extremely tiny board that has one of the U-blocks ZED F9T modules on it. That's the expensive one. We also can put a less expensive module on as well for a lower cost option, but the dual frequency one is needed for some of the science that the Hamvention group wants to be able to do. There's a TCXO and a synthesizer chip, so we can get the signals that we need to run everything on the data engine and the TangerineSDR. We can get pulse per second timing signals. We also have additional signals that are accessible. So it's the time source for the Tangerine. We're also going to have a separate carrier board that it can mount on, so that if you're a time nut, you can have access to all 10, count them, 10 independent RF outputs that can be programmed into the chip. You can use an external reference rather than the GPS module if you want. So, very cool. We're working on getting that designed. This is not a high-performance GPS DO because the space limitations, this board is like 35 by 35 millimeters. It's just, insane small. The TCXO that we're using is 4.5 by 5.5 millimeters. You can't have a whole lot of thermal control in a package that size. So this is modest performance. It will be similar to what the Leo Bodnar GPS DO does, but it's very flexible and has a lot of very useful characteristics, but it's not a laboratory GPS physical oscillator by itself, but I think it'll still be useful for a lot of things. We've built a bunch of those prototypes. They work. There were 2 wiring errors. You can see on the picture there are 2 blue wires. There's also a little resistor stacked on top of another. There are easy things to fix, fortunately, and with those reworks, the boards work just fine. We have not been able to do more than the basic functionality because to do all the programming and the different output frequencies and everything, we need to be able to integrate it with the data engine and the FPGA firmware, which, as Dave mentioned, isn't quite there yet. So we know the hardware works, we don't know how well it works. So that is about it. I'm happy to take any questions if we have time now, or at the booth I'll be there all weekend. Yeah. Stay by Mike.
For the GPS DO, characterize its Allen variant?
I have characterized, I'm sorry, yeah, and we characterized the Allen deviation or Allen variance of the clock module GPS DO. I have measured the development boards that put together to make the thing, and the performance is similar to the Bodnar, a little bit better in some places, a little bit worse in others. I haven't been able to do more complete testing because we've only been able to get the most basic functionality out of it and haven't been able to experiment with the different filter bandwidths and things that might be able to optimize it. But we know it works.
And that other picture you showed with the stack of uglies?
Yeah.
Just out of curiosity, what are you using for your time interval counter?
For the timing measures, I use a multi-tick, which is the 4 ticks in one box for 8 outputs, and then usually either a cesium reference or a hydrogen maser is the reference clock for doing the timing. And one of the things that I want to do out of this experiment that's going to be challenging is I want to get the absolute time difference of the different receivers to see what kind of biases and delays there are in the circuits. And it's easy to do over time, but to get the actual number of nanoseconds, you have to design things more carefully, and I'm kind of working on putting that together.
Have you found a good source for cheap hydrogen maybe?
You have to look real hard, and if you buy one on eBay, look for the shipping charges.
Yeah, I think bigger, I want to. Here.
Yeah, Jim has, Jim Jager down said he has an old maser. I think it needs a little bit of work to get it going again, but it's a full-size big one. I was able to get a passive, which is a smaller, doesn't perform as well. Yeah, but it's a lot cheaper and a lot smaller.
It is heavy.